In this installment of the Career Chronicles and Industry Insights, I am very, very pleased to be welcomed by Suresh Sugumar. Welcome, Suresh.
Thank you. It's a great pleasure to meet you.
Absolutely. Suresh has a storied history being at Intel, Qualcomm, MediaTek, back to Intel, and he has architected and led teams that have been responsible for some of the industry's most interesting processors. So very, very excited to speak with you and to learn a little bit about your career.
Sure. I'm Suresh, just like you mentioned, and then I spent the last 20 years working on chip architectures, the oldest being with Intel. And I worked in client and data center departments, contributing to hardware design, designing TEEs, so-called trusted execution environments, power management, microcode, and a few other things that caught my interest at that time. And then I moved to a few other companies like Qualcomm and MediaTek, doing custom CPU designs for them. And most recently, I served as an executive director in a research firm in the Middle East. I was doing design and architecture for zero trust, open source, RISC-V chip development, and also contributed to AI platform that was being developed here. And over this journey, I was fortunate to accumulate about 15 to 20 US patents and many conference papers. And also managed to have an MBA for my entrepreneurship aspirations. Apart from work, I also contribute to RISC-V International Foundation. So I serve as a vice chair for the AI ML group that develops RISC-V extensions, so we call ISA extensions, to improve its AI ML capabilities. For example, how can you run transformer models faster? So that sort of work, which we will talk about maybe perhaps in a later time. And after 20 years, I decided to pursue my entrepreneurship journey. And I'm sort of making my AI company that will design a radically new hardware. Details yet to come. So.
Well, you're jumping ahead. I'm going to want to come back to that, but I'm always curious with people as prolific as you are to learn what got you into engineering to begin with.
Okay, so it's a long story. When I was 7 or 8, I wanted to be an astronaut or a mason or a guitarist. And then one weekend, I noticed my dad, he was dipping some plastic board in some solution. And after a while, it turned out to be a circuit. I was like, what is this? And then he started assembling some components on top. It became a calculator. That really caught my attention. Hey, a bunch of things you assemble and then it's able to do math. So that really got my attention. And then I told my dad, hey, I'm going to build computers like you. And at that time, I don't know if you remember, they used to show the bunny suit ads for the Pentium processors. Yep. So I used to watch Intel. That, and I told my parents, one day I'm going to go there and dance like that. And then dance didn't happen, but I eventually joined Intel. My career path took it that way. Basically, low-level system programming, hardware design, and that shaped my career from there.
So, and you've been very intentional about getting in the AI ML space. That's an area of passion, and you've been focused on leading architectural teams for many years. Can you share with us your thoughts on the current state of chip architecture for AI machine learning workloads specifically? Meaning, what do you see the most significant trends and opportunities right now?
Okay, so first of all, looking at what's happening, ever since CPUs were doing miserable for AI, and then people repurpose GPUs for that purpose, things started changing, and then it sort of accelerated deep learning some 10 years ago. From then onwards, I think a lot of people understood, okay, repurposing some hardware for AI may not be the most optimal thing. So people started coming up with their own custom AI accelerators. So there are 4 segments: cloud training, cloud inferencing, edge training, and edge inferencing. So people are targeting some of these segments with their own custom chips. For example, apart from GPUs, there are companies making RISC-V, even wafer scale chips, and which has millions of cores. And then people are even building analog processors, which are sort of memristor based. So a variety of things have come, and they are being explored. And then it's promising, but we haven't made that final thing. Hey, this is it. So there are some challenges which I will get to, why we have some problems. And on the RISC-V side of things, we sort of believe that CPUs can be a good hardware for inferencing if you enhance it with extensions and capabilities, just like we had floating point unit to speed up floating point operations. So if you have some things for AI, for example, matrix multiplication extension, and looking at new ways of representing numbers like POSIT or logarithmic, are interesting ways to to faster and efficient number crunching. So these are some things that could potentially make RISC-V an interesting candidate. Having said that, we are still on the surface, right? So the important issues with AI that I see are the electricity consumption and the cooling. So some numbers I digged up from Hugging Face. So if you want to train a 13 billion parameter large language model, which has around 400 billion tokens, you need 200 odd GPUs for 7 days, and the bill you pay is $150,000. This is just a small model, and then imagine you have 100+ billion parameter model, something like ChatGPT and stuff, easily going to cost 10 million. So what does that mean? Companies with deep pockets are only able to do this sort of research and development at this point of time. This is the opposite of democratization. So if you really want to make a prolific impact and help humanity, we got to change this. And one more parameter we found by a research by University of California. They figured out that every query you send to ChatGPT, they need to cool the system using half a liter of water. That's insane, right? Why would you type a query? Because you're hurting the environment. It's not a good thing. So, so we'll get to a point where, okay, what are my recommendations, or not just mine, what all the generic recommendations to address this problem? I see a few trends as well. So hardware has enabled the growth of deep learning a decade ago, but at this time, that's inhibiting the progress because of the cost of hardware. For example, if you want to buy a GPU, it's on the top of $30,000, $40,000. How many can afford? So that's one bottleneck. And a few other things like, you're coming up with new architectures, but the cost is not going down. So the accessibility is the big problem. And another trend that's happening is moving away from sort of the service-based model. For example, one service provider provides AI service similar to ChatGPT, and people sign up as a subscription, and then they used to use it. But now things are a little bit changing, where they think about their privacy and security and a whole lot of other things, and then they want to have private on-premise AI. So demand is going up, but the implementation is hard, because you need to spend a huge lot of money on CapEx buying these equipments, and then having your own models getting trained. It's really hard. So there is a tug war going between, okay, what's the right thing to do? And the moment you see that your CapEx expense are really high, you might think, okay, should I go for service model? So it's a conflict at this point of time. So this is exactly the opportunity I am going after. Make AI democratizable and make AI sustainable. We will talk about the details on how exactly I plan to do that in the future section.
Okay. Well, you've introduced it. So talk to us a little bit about the ideas that you have to solve these, because as you know, democratization of AI and responsible AI is at my heart, and it's a fundamental belief of mine of the criticality of the continued growth of AI. So tell us a little bit about how you would go about solving that.
Okay. So the three burning problems, like you said, democratization, responsible AI, and sustainable AI. So these are the three things I would like to personally contribute to. So fundamentally, this can be done by coming up with the radical hardware designs that are fundamentally more energy efficient. I would say 100 to 1000x than today's systems. So just imagine, right? The brain is so powerful. It's able to do so many things in parallel, but it just consumes 10 watts compared to these ginormous supercomputers that run these models with megawatt power supplies and cooling, like I mentioned. There's something out of proportion, and perhaps we are doing something wrong here. Things are working, it's great, but there needs to be, we need to take a look what is wrong. Coming up with a fundamentally new architecture. I know people are experimenting with a whole lot of new paradigms, like coming up with analog models, and rethinking about the floating point number system, looking at posits, looking at logarithmic computing. But personally, I think they will take you somewhere, but they are not going to cut it. If you really want to advance AI research and go to a level where you call it pre-AGI, basically general intelligence. So an example I would give for this is the character Samantha in the movie called Her. It's a classic representation of what we want to see, a real human-like assistant that would be with you all the time, understands you. That's where we want to go. Then the pace in which we do, the way in which we burn electricity is not sustainable. So the idea would be to come up with neuromorphic hardware designs that mimic human brain. So in theory, the energy consumption should be really, really low, because it doesn't burn power doing matrix multiplications for everything. It selectively does operations, and then it produces a result. And we have to adopt all these models into a new model called the spiking models. So for example, if you convert the transformer model to spiking transformer, and then you make it run on this new platform, that will be the ultimate solution for this. So I expect the energy to be almost 100 to 1000x lower than what we burn today. and then it would not need this much cooling, and it will be faster. So what that means is you don't need big data centers or AI supercomputers to train all these models and then burn this much dollars. So I assume it would be just like a PC. So the huge data center will shrink to something like a small computer. You and me can have it in our home, and we could be able to train models as we wish. That's the goal, and that solves many problems. Responsible AI is where, yeah, you take care of what you protect. You make sure your model is fine-tuned to take care of the users, and you don't really depend on a third party to take care of you. So that way we can have the control of what the model should do. And from the last thing about sustainability, if this doesn't burn the power like what it used to do, it's fantastic. So the CO2 emissions and a whole lot of other problems will just disappear.
Got it. So, in theory, it sounds great. Recreate the human brains in chip form. How far along are you in your research because there are obviously people who have tried this before and that are currently trying this. What are you doing different?
So there were many attempts in the past. Some of the big players have even taped out a neuromorphic hardware even recently. And at this point of time, they are focusing on computer vision and kind of models to run there. And there is even a company that sells neuromorphic hardware that sits in your car, looking at, okay, what's going on, who is trying to get into the car sort of model. But really, I'm blowing up that scale and putting the recent transformer models there. That means, yeah, the challenge is huge. The hardware has to be big. We need to repurpose that hardware to this particular model, and so the scale is huge. From a small computer vision system to a big large language model processor, the scale will be huge. And the good thing is, since people have tried on a small problem, technically it should be easy to scale it up, and a whole lot of work would be needed to adopt these models to run efficiently on this new platform. So that's one challenge. And then I don't think it's a big blocker, but of course it'll take time to get it right. It may not be the best in the first run, but my expectation and back of the envelope calculations say it's technically possible, and we could really simulate that from 6 months to 1 year. We could really have something that can prove this concept actually works. So that's where I'm headed.
What can those that are excited about this vision, and I'm not sure who wouldn't be excited about solving the 3 biggest problems within AI, how could they be a part of helping you? How could they get behind this with you?
Yeah, so there are 2 ways. One is, of course, collaboration. So, of course, I can't do everything by myself. There are a lot of experts on neuromorphic computing, neuroscience researchers, hardware experts, and model experts. So one good thing is to reach out, and then we could collaborate as part of this startup. And the second way is by providing investment support. So that way we can really make something big happen.
Okay. And how would you like people to reach out to you to either collaborate or to talk with you more about potential investment support?
Yeah, sure. They can just search my name, Suresh Sugumar, on Google or LinkedIn, or reach me by email, firstname.lastname@gmail.com. be happy to help them.
Well, I know it's late where you are, and so I'm incredibly grateful for you spending the time to share your passion behind the democratization, the sustainability, and overall responsible AI development. Really appreciate the time that you spent today and the education that I've received. Thank you.
Thanks to you as well. Yeah, it's a great opportunity for me to share to the rest of the world.